This is called the cross-eyed method for multiplying fractions. So the cross-eyed method is canceling before multiplying fractions. Using the cross-eyed method is a great way to make multiplying fractions easier. The process is known to most as canceling, but calling it the cross-eyed method is fun. Plus, it will help you remember how it works. Just how to do it. Before multiplying two fractions, find the numerator of one and the denominator of the other, cross eyes. Check to see if they share a common factor. If they do, divide both by that common factor. The answer you get becomes your new numerator and denominator. So for example, in 6/10 times 7/18, if I look at the numerator and denominator, so if I go across, that's why it's called cross-eyed, is 6 and 18. Both 6 and 18 are divisible by 6. So I can divide them both by 6. So divided by 6, divided by 6. So in the second step, I ended up crossing them out. So I crossed out the 6, crossed out the 18. The 6 became a 1, and the 18 became a 3. And then a common factor of 6 and 18 is 6. So both numbers are divided by 6, and the answer replaces the original numbers, multiplying using the new numbers. So then I look at 7 and 10. There's nothing that I can do with 7 and 10. They don't have a common factor, so they just stay the same. So now I have two new fractions, basically. I basically have 1/10 times 7/3. So then when I multiply straight across, I get 7/30, and I'm done. I don't have to simplify. So it simplifies my fraction before I even start to multiply. Okay. So sometimes the cross-eyed numerator and denominators are the same number. This means that both cancel to 1. So in this example, I have 3 and 3. They both come to 1. So now I'm multiplying 1 times 1 and 4 times 1. So I get 1/4 as my answer. Once you canceled, you just multiply straight across. Sometimes both cross eyes can be canceled. Like in this example. So in this example, I have 14 and 7. They can both be divisible by 7. I get 2 and 1 when I cross cancel. And this one, I have 3 and 15. They're both divisible by 3. So now my new fraction is 2/5 and 1/1. So I multiply and I just get 2/5. So it says, note that some pairs of fractions cannot be canceled and must be multiplied as the problem is written. When we cancel, the numbers get smaller and are easiest to deal with. You're actually reducing the answer to lowest terms before you multiply. And it says this method can be used when dividing fractions too. Just remember to invert the second fraction and write it as multiplication before you cancel. So you can keep, change, flip, and then use this method. Okay, so here are some examples. So we're going to look diagonally at them. So we're going to look at 5 and 10 first. So this one, you're just going to write it down in your notebook. We're going to do couple together, and then I'm going to stop the video. You're going to try it on your own, and then then we'll go over the answer together. So I look at 5 and 10. I do know that 5 and 10 both have something that's divisible. 5 goes into both of them. 7 and 9, though, when I look at them, that's not true of 7 and 9. So I can't use this method for the 7 and 9. So I'm going to cross out the 5. 5 divided by 5 gives me 1. Cross out the 10. 10 divided by 5 gives me 2. And then I multiply straight across. 1 times 7 is 7. 9 times 2 is 18. And then I have my final answer. So it makes the numbers much easier to work with. So let's try another one together. So I have 2/15 times 3/4. So I look diagonally, and I know 2 and 4 have a common factor, and so does 3 and 15. So for 2 and 4, 2 goes into both of them. 2 divided by 2 is going to give me 1. 4 divided by 2 is going to give me 2. So that's my new numbers. Then 3 and 15, 3 divided by 3 is 1. 15 divided by 3 is 5. And then I multiply straight across, and I'm going to end up with 1 times 1 is 1, 5 times 2 is 10. Okay. For this one again, I look diagonally. I notice 4 and 12, they have a common factor. 5 and 5 are the same number, so they have a common factor. So then 4 and 12, I cross out the 4 and I get a 1. The 12 divided by 4 is going to give me 3. Cross out the 5 gives me 1. 1. I'm going to multiply straight across. 1 times 1 is 1. 1 times 3 is 3. Okay, last example we'll do together, and then you're going to try a couple on your own. So most of the time, one of the numbers goes straight into the other, but sometimes it doesn't. So 6 and 9, those have a common factor. 2 and 7 do not. So I'm going to divide 6 and 9 both by 3. I'm going to show that I divided by 3. Cross it out. 9 divided by 3 is 3. 6 divided by 3 is 2. Then I'm going to multiply straight across, and I get 4. 7 times 3 is 21. So it just makes the numbers a little bit easier to use. Okay, so everyone try this one on your own. Okay, and when you get the answer, and then we'll go over it together. Okay. 25 and 50 do have a common factor. It's 25. 9 and 27 is 3. So 25 divided by 25 gives me 1. 50 divided by 25 gives me 2. And then 9, I'm going to divide it by 9, which will give me 1. 27 divided by 9 is 3. So when I multiply straight across, I get 1 times 1 is 1. 3 times 2 is 6. So much easier than doing 25 times 9 and 27 times 50. Okay, try this one on your own, and then we'll check our answer. Okay, so I noticed that 1 and 7 do not have a common factor, but 3 and 3 are the same number. So I end up crossing those out. They both become 1s. 1 times 1 is 1. 1 times 7 is 7. So I get 1/7. Okay, same with this one. So try this one on your own, and then we'll go over it. So 14 and 28 do have a common factor of 14. 11 and 33 have a common factor of 3. So 14 divided by 14 is going to give me a 1. 28 is going to give me a 2. 11 divided by 11 is going to give me a 1. 33 divided by 11 is going to give me a 3. Multiply straight across, and I have 1/6. Okay, try this one on your own. So I notice that 6 and 8 have a common factor. They're both divisible by 2. 7 and 10 do not, so those stay alone. So then 2 goes into 6 3 times. 2 goes into 8 4 times. So I multiply straight across. 3 times 7 is 21. 10 times 4 is 40. Okay, so now make sure that you are working through these same kinds of problems. Make sure that you check first if you can simplify before doing any of the practice problems.